Come and dance with us.
Explicit differentiation is used when y is already written in terms of x, like y equal f of x. You just differentiate both sides normally. Implicit differentiation is used when y is mixed with x in an equation, like x squared plus y squared equal 25. Since y depends on x, you apply the chain rule when differentiating terms with y.
Hi, I am in front of you to teach you how to solve for the implicit differentiation. So here in my hand, I have a function that is implicitly expressed. So 3 plus y raised to 9 minus 45x raised to 6 plus y squared is equal to 10x raised to 4 minus 5. So here we are going to use the derivatives as well as chain rule that we lesson a few weeks ago. So the derivative of 3 is 0 that we don't have to write anymore, and then the derivative of y raised to 9 is equal to 9y raised to 8, and we are going to add dy over dx. Since it is a y variable, if it's a y variable, we always have to add dy over dx to it. So next is the derivative of negative 45x raised to 6, which is equal to negative 270x raised to 5, and then the derivative of y raised to 2 is equal to 2y, and we are going to add dy over dx is equal to the derivative of 10x raised to 4 is equal to 40x raised to t. So we are going to write it down. The derivative of negative 5, however, is we are not going to write anymore as it is equals to 0. Okay, so here what we have is our goal is to isolate the dy over dx. So every function that has x in it will be moved to the right side using a b. So we are going to copy 9y raised to 8 dy over dx, and then we are going to skip this part, so we are going to put it in the right side of the function. We are going to write 2y dy over dx is equal to 270x raised to 5 plus 40x raised to 3. So there. Now what we're going to do is to factor out the dy over dx. dy over dx multiplied by 9y raised to 8 plus 2y, and then is equals to 270x raised to 5 plus 40x raised to 3. If you are kind of confused why we didn't simplify this part, it is because of the power. Their power is not the same, therefore we cannot simplify it. So here we are going to divide both sides by 9y raised to 8 plus 2y, 9y raised to 8 plus 2y, 9y raised to 8 plus 2y, and then cancel this out. What we're going to have now is dy over dx is equal to 270x raised to 5 plus 40x raised to 3 all over 9y raised to 8 plus 2y. The derivative of y with respect to x is equal to 270x raised to 5 plus 40x raised to 3 over 9y raised to 8 plus 2y.
This example, I'm going to teach you how to solve implicit differentiation with other way. With this problem, so we have to find the dx over dy of the given 4x cubed plus 8xy plus y squared equals 18. So let's start. In this problem, we'll just simply need to find the derivative of y with respect to x with this given 4x cubed plus 8xy plus y squared equals 18. To find the derivative of y with respect to x, we'll just simply need to differentiate all of this term with derivative of y with respect to x. So we're just simply going to take the differentiation of differentiate this given with d over dx. So every term 4x cubed plus 8xy plus y squared equals 18. To take the differentiation, we're just going to take the derivative of each term. So the derivative of 4x cubed with the basic rule, we'll just simply need to multiply the exponent by its coefficient and subtract number 1 to the exponent. So 8 times 4 is 12x. G minus 1 is 2, so 12x squared. Now, for this problem, for this term, it has double variables. We have x and y. For this term, we're going to use the power rule. We'll just simply need to separate each variable. We have 8x for f and y for our g. The power rule is simply just d over dx equals f times g equals f prime, the derivative of f times g plus f times the derivative of g. That's the power rule. So in this problem, we have f derivative of f, so our f is this, the first part, so the derivative of 8x is 8f, and the derivative, and with our first part we have g, so y, plus f we have 8x, and for our derivative of g we have y, so y, every variable is equals to 1, so 1, but since we have to respect the x, we just simply need to add here dy over x. Now let's proceed to the next term. We have y squared, so the derivative of y squared is 2y. Now we have to respect the x, so we just simply need to add a dy over dx here. And the last, we have a constant term. So every constant term is equals to 0 when taking the derivative of it. So it's 0. From this, we have to isolate every term that has a dy over dx. Each term, so we have 8x times 1, we have 8x and 2y. So let's put it in here. Every term that has not dy over dx will be moved from the other side of the equation. So 12x squared from positive, we have to transpose it to the other side. So it's going to be a negative 12x squared, and 8y, 8 times y is 8y. So positive 8y will be transposed to the other side. So it will going to be a negative sign. Now let's transpose the terms that has not a dy over dx. So we have 12x squared minus 8y. It's going to be a negative 12x squared minus 8y. Since from positive we transpose it to the other side, so it's going to be a negative sign. And to cancel out this, we have to divide it from 8x plus 2y. So 8x plus 2y over 8x plus 2y is going to be cancelled. So now we simply have a final answer. We have negative 12x squared minus 8y over 8x plus 2y. So in our answer, we have the derivative of y with respect to x is negative 12x squared minus 8y over 8x plus 2y.
Here's the example. Derivative of variable raised to variable with respect to x. How will we get the derivative of this problem using logarithmic differentiation? So we have y is equals to x raised to x. We will using the natural log to bring down this exponent to this side. So we have natural log of y is equals to natural log of x raised to x. We will bring down the exponent of natural log of x raised to x here. So we have natural log of y is equals to x natural log of x. We can get the derivative of these both sides. So we have derivative of natural log of y with respect to x is equals to derivative of x natural log of x with respect to x. First, to get the derivative of this side, we will using the formula of derivative of f times g with respect to x is equals to f prime g plus f g prime. So we have the derivative of natural log of y is equals to 1 over y times dy over dx is equals to the derivative of x, which is the f, is 1 ln x or natural log of x plus the derivative of the natural log of x is x times, we will get the x here, and then the natural log of x, derivative of natural log of x is equals to 1 over x. So we have 1y dy over dx is equals to natural log of x plus we will cancel the x to have 1. Next, we will divide it to y, we will times it to y, this both side. To cancel this, to have derivative dy over dx is equals to y quantity of natural log of x plus 1. Remember this, we will replace the y into x raised to x. So we have dy over dx is equals to x raised to x with the quantity of natural log of x plus 1. This is the final answer of this using logarithmic differentiation.